I request to Mr. Kiran Kumar to introduce Dr. Sahya Bhaskaran garu.
Kiran sir, please unmute. Kiran sir.
Good evening, all of you. Good evening to all the dignitaries in this call and my dear colleague friends. Myself, I am Kiran Kumar, School Assistant Physical Science from JPH School, Bejupuram, Laveru Mandalam, Srikakulam district. So it's my privilege to introduce this personality. He is none other than Dr. G. Sahya Bhaskaran. Dr. G. Sahya Bhaskaran serving Andhra Pradesh College as the Professor of Physics since 1990. He has 51 publications in the international journals related to glass materials. He has successfully guided 3 scholars into PhD and 7 scholars have completed MPhil under his guidance. His areas of specialization include biomaterials and software development on disability studies. He is serving the students with visual impairments to get trained and placed in various positions. He has acted as a resource person for the academic staff college Tirupati on ICT tools in teaching and research. This is a small brief about this wonderful personality. And now I am welcoming him onto this Zoom call to give his wonderful speech and teachings on application of photoelectric effect. Please welcome, sir.
Thank you, sir. Thank you, Kiran Kumar, Kiran sir, and Srinivas Rao garu, Lakshman Rao garu, my guru Sanyas Rao sir, and also Dr. Chandrasekhar, and all fellow teachers from Srikakulam and other places. Good evening and a hearty welcome to this short talk for 15 minutes on applications of photoelectric effect. Professor Sanyas Rao garu has given the narrative of the historical background and also the idea, how an idea can change the whole world, the way we understand matter, the way we understand energy, the way we understand light, the whole thing has changed. That's the significance of Einstein's contribution. So Sahya has given the historic background. A simple idea, even though Einstein was happened to work in as a patent office, he never left the passion for science. Perhaps that one value, it is within all of us, and that unites all of us. And let us see how the importance, what is the importance of photoelectric effect. Is my presentation visible, sir?
Yes, sir.
Sir, is the presentation visible?
Yes, sir. Yes, sir. Visible.
Yes, sir.
Carry on, sir. Yes, sir.
Full screen, right?
Yes, sir. Yes, sir.
Yeah. So those who cannot see, you can pin the presentation. I think there are 2. Yeah. Thank you, sir. So my role as requested by Srinivas Rao sir is to give some of the applications of photoelectric effect within 15 minutes. I will try to confine because I'm also expecting like you to have a presence of Shri Verma ji and also the demonstration by my good friend Dr. Chandrasekhar ji. So I will confine to very briefly. So these 100 years of Nobel Prize has changed the whole world into thousands of years. That's the significance. That's the importance of a great mind. Of course, we all know that Einstein is the greatest scientist of the whole world has seen. The whole millennium is a man of millennium, right? So with all this, what is the significance? So our Professor sir has given nicely. Just move, yeah. About the photoelectric effect and also the ideas behind that. I'm not going to repeat. Just one thing, what we have to look at this is when photons fall, when photons, which is light, fall on a metal, electrons are ejected. Yes, this is what we say simply photoelectric effect, right? Earlier, so in the 18th century, there were discoveries on diffraction, interference, polarization. So all those theories have proved light is a wave. Light is a wave. That was the idea. So during that period, to give something different, to give something which is not a conventional. కొత్తది ఒకటి చెప్పడం అనేది చాలా గ్రేట్. మేబీ దాట్ ఈస్ ద థింగ్. సో ఈ థియరీలో ఐన్స్టీన్ ఏం చెప్తున్నారు? లైట్ is behaving like a particle, again back to corpuscular nature, right? So this idea originally, as sir was rightly pointing out, Millikan wanted to disprove that, but truth is always triumphs, right? So Millikan himself has to accept, and in fact Millikan's acceptance gave the Nobel Prize for Einstein also. So this is something we should not always look for the conventional thing. We should not always accept what is already there. We should always try to make innovations, new ways of teaching, new ways of looking at things, new way of making research. Perhaps that one lesson I also, from Sar's lesson, I also got to my life. So now coming to the point. Yeah. So basically what we have to understand, what we have to key to understand all these applications is light, when the photoelectric effect takes place only with a shorter wavelength. Otherwise, when lambda is less, frequency is more, h nu is more. So h nu of the photons or beyond a level, beyond a threshold, only then photoelectric effect takes place. Even though your sir nicely has given that. So even though if it is a bright light, even though it is a bright red light, no photoelectric effect. But a dull ultraviolet or a dull blue, that could produce photoelectric effect. Why? The wavelength of the blue is less, and so once the wavelength is less, we know the frequency is higher, 1 by lambda, c by lambda. The frequency is more, and h nu, energy of the photons, are more. So this one thing we need to remind for all our applications. Then kinetic energy. Yes, what is the kinetic energy of the emitted photons? Yes, so kinetic energy of the emitted photon is whatever is the energy of the incident photon minus the work function. Work function is something, suppose the electron is there on the surface, to bring it to the surface, the electron is revolving around the nucleus, just to get out of it, just to bring it outside the new influence of nucleus. What is the energy required? Or just to bring it to the surface of the metal, that energy is the work function. So once that is over, whatever is the excess energy, so everything from the original energy is h nu, something is spent, and remaining all comes as the kinetic energy. So this one beautiful idea of Newton led to so many applications, which we are going to see one by one now within short time. So this is another way of illustration. So we want to have a photoelectric effect, lower wavelength, violet is suitable, or even ultraviolet may be better, but the higher wavelengths means lower frequencies cannot emit the electrons. This is a graph. And kinetic energy depends on frequency. The increase in kinetic energy depends on, when the frequency increases, kinetic energy also increases. So kinetic energy, or the speed of the electrons that is coming out of the metal, doesn't depends upon intensity. Yes, so this one thing we need to keep in mind. So whatever is the so because of that, they are able to prove, right, the number of increase in intensity, or number of photon increases, number of electrons are ejected, that also increases. This property is useful in number of applications, right? So when light falls, so many things happen. When light falls on a solar cell, when light falls on a photofilm, or when light falls on a CCD device, or when light falls on a light meter, let us see what happens. First, let me begin with the photoelectric cell, right? So this also Sahya has nicely explained as an experiment. Is the mouse is visible? Yeah.
Yes, sir.
Sir, visible, sir. Sir,
Mouse is
visible.
right?
Yeah,
okay.
visible.
Right. So here, when light falls on the cathode, right? So we are giving a proper potential. And what happens when there is no proper potential difference? When light falls, current flows. Simple. We are trying to understand like that. When light falls, current flows. So this is the simplest way of understanding a photoelectric cell. 1900s, 1920, 1930, so many devices have come based on this 1930. So some of this, the basic thing is photoelectric cell, right? So it is also called as electric eye, photocell, phototube. All these are different variants, slight modifications of the photoelectric cell, which is based on photoelectric effect. When light falls, current comes. That's all. When light falls, electrons are emitted, so circuit is complete. So current flows in the circuit, right? So light falls, you can create or you can make a current to flow in a particular circuit. So this one simple thing led to so many devices like solar cells. Even today we are talking, we are connected through our internet. So that is for the same internet, the backbone is fiber optical communication, the internet, right? For the internet is working based on optical communication, fiber optics. So there again, we use the photodiodes. So all these discoveries, the origin is Einstein's understanding, right? So this is the beginning, and the first one, photocell, different variants of photocell, and till today what we are using, photodiode for fiber optical communication. All these applications, all the practical uses are possible because of Einstein's theory or the understanding of the correct understanding of the photoelectric effect. Yes, right. So previously, those days, the photocell was used as a control system. So which means we might have also used to do it in our science exhibitions, right? So when light is abstracted, the circuit current will not flow, and based on that, you can make a relay, and that relay will control. So either it gives an alarm or it closes the door, open the door. All these kind of all these kind of applications they were used, and later the same photocell was developed into a photomultiplier tube. So this photomultiplier tube has got enormous applications, right? So basically, what is a photomultiplier? The photoelectric current, what is the output of a photoelectric effect from a photocell is very small, microamperes. So that cannot be detected in a normal way. So you need to develop it by having number of diodes, a device called diode, right? A small photodiode called diodes. Suppose you are allowing from first diode to second to third. If you go on expanding, finally you will have some millivolt or a considerable amount of either current, milliampere, or voltage. So that could be detected. This is the principle of photomultiplier. So photoelectric effect, number of diodes if you have, again you can use this to detect even one photon. A single photon can also be detected. Just one photon comes and falls, there is some response, right? If it is in very small microampere, you cannot detect, and you need to multiply just like amplification process. And such kind of photomultipliers are used in spectroscopy. Today we are using in our research like a spectrophotometer. No, depending upon absorption of light, what is the composition of the crystal, what is the composition of the chemical composition, all these we are analyzing use our optical spectrophotometer. What is there inside? Photomultiplier tube is there. Similarly, no, of course, we are also studying the composition of the star. What type of gases unnai, idanni kuda dantlo unna spectrum analysis ni batti cheyochu. Idanni kuda manaku photomultiplier anadi chala paniki vastundi. Computerized axial tomography. So it is nothing but body scan, right? SCAT. Computerized axial tomography is the scanning process. It's used for in the medical field. So again, what we are using today, the scanning starts. The seed is the Einstein's understanding of photoelectric effect. And other applications of photodiodes and photomultipliers are imaging technology. Imaging technology is nothing but old camera technique. Nowadays, what camera we are using is different. I will come to that, CCD based. But old television camera is also based on this photomultiplier tubes only. Of course, we might have studied in our degree the old type of television camera, but now no one is using that. Everything becomes digital. Nowadays, they are not even using camera, they are using cell phone only for even picturizing the outdoor events, especially the TV. And nuclear processes also, even a minute charges that comes out of any nuclear reaction could be detected. So you can understand the nuclear reactions. Again, the same tubes are useful. Chemical analyzing, as I told you, the optical spectrophotometer. If you take the optical absorption spectra, that will give the idea of the chemical composition of the material, and also theoretical information about how electrons in atoms transition between two different energy states, how the electrons are excited, how they are releasing energy. What are the excited states, how you are mixing in a rare earth, what type of composition it takes place. All this we can study using this ones. So in general, what I can, based on this, what we can conclude is the physicists, the idea of the physicists to completely reorient. Previously, they thought only wave is the thing. Later, we are saying dual nature, right? So the wave light can also behave like a particle, the nature of light and structure of atom, and entirely new way of understanding as it led to that. And similarly, photovoltaic cell. So this is nothing but our solar panel. This is a solar panel. The solar panel, if you are expanding one, you will get in the reverse way. You will get a number of small things. They are called solar cell. In each cell, when light falls, sunlight, when solar energy or when light falls, photovoltaic cell is producing small voltage like 0.5 volts. Each cell is capable of producing some 0.5 volts. Now, if you are connecting number of solar module, so this module, number of such modules are there in one panel, 1 meter to 1 meter panel we have. So that is able to produce sufficient voltage to drive the charger or to drive one or two tube lights, fans like that. So this again, of course, it is producing DC, and DC current is using an inverter converted, and for domestic purpose we are using today. So origin is Einstein. So the photo electric effect and photovoltaic effect, both are similar. So if you have a solar cell, if you study that, similar property. Only thing is, in photoelectric effect, electrons are ejected out. They come out of the metal surface. But here they are using some N-type and P-type semiconductor, photovoltaic N-type and P-type silica-based semiconductors. There, the ejected electrons are not coming out, but they are circulating. Somehow they are circulating inside, and that process is making all the production of making some potential difference, and that enable to have some current. Similarly, light meter. Yes, so this is used in shooting spot, as well as those days they used to the sophisticated camera. They want to fix the exposure time, of the camera, the old camera exposure time, as well as the speed exposure. All these were detected using light meter. What is the concept? Same concept. When light falls, it lead to a small current. By processing what is the amount of current generated, we can understand the intensity of the light, right? So again, we already told you the intensity is related to number of photons being falling, and that gives more and more electron, more and more photocurrent, right? So this kind of devices are used in shooting, film making, even today, to have the uniform illumination. They test it, otherwise they adjust the lighting condition. So all these light meter is one of the device. Second device is selenium meter. Selenium meter is also another instrument. So this is used also for automatically adjusting the exposure value, right? For example, in a camera like this, of course now we are not using this. Everything comes in the cell phone, but cell phone having the same principle. The origin is same, but of course the cell phone has got the app, or it has got the processing capacity, so that it guesses the value, or it adjusts the exposure and all these things. But old days, even of course some of the professionals use this kind of camera with sophisticated lenses and all. So it also has got selenium meter. This selenium meter will automatically adjust. So automatic camera antunam kada manam 20 years 30 years back itla undi undadi. So automatic camera lo itla undi light detection e vadutunnaru. అలానే ఎలక్ట్రిక్ ఐ అన్నది ఇది. ఎలక్ట్రిక్ ఐ అన్నది ఏంటిది, మనం ఎగ్జిబిషన్స్ లో పెడుతున్నాం థెఫ్ట్ అలామ్ పెడుతున్నాం కదా, అది నథింగ్ బట్ ఎలక్ట్రిక్ ఐ ఆర్ ఫోటో డిటెక్టర్. ఫోటో అంటే లైట్. సో ప్రెసెన్స్ ఆఫ్ లైట్ ఆర్ అబ్సెన్స్ ఆఫ్ లైట్ ఇస్ దేర్ ఆర్ నాట్, అది మనం ఎలక్ట్రిక్ ఐ ఆర్ ఫోటో డిటెక్టర్ ద్వారా చూడవచ్చు. మనం అందరూ ఎగ్జిబిషన్స్ లో చూస్తూ ఉంటాం. మీరు ఎక్కువ మన పిల్లలు కూడా చాలా మంది ఎగ్జిబిట్స్ చేస్తారు థెఫ్ట్ అలామ్ అని, ఆర్ ఇఫ్ యు ఆర్ మేకింగ్ అబ్స్ట్రగల్ ద డోర్ విల్ క్లోజ్ ఆర్ డోర్ విల్ ఓపెన్, ఇట్లాంటి ఆటోమేటిక్ థింగ్స్. దాంట్లో ఏముంది, లైట్ ఉందా లేదా, ప్రెసెన్స్ ఆఫ్ లైట్, అంతే కాన్సెప్ట్. లైట్ వస్తే ఒక మాదిరి, లైట్ రాలేదంటే ఏంటి, మేబీ కరెంట్ ఇస్ డిక్రీస్డ్, అకార్డింగ్లీ ఇట్ విల్ బి సెంట్ టు ఎ రిలే అండ్ దట్ రిలే విల్ కంట్రోల్ ద డివైస్. సో దిస్ కైండ్ ఆఫ్ ఎలక్ట్రిక్ ఐ అనేది కూడా ఆ రోజు నుంచి ఈ రోజు వరకు ఉంది, మన ఎగ్జిబిషన్స్ లో వాడుతున్నాము. అలానే మూవీ ఫిల్మ్ ఆడియో ట్రాక్ కూడా, ఇక్కడ ఫిల్మ్ లో థియేటర్ లో ఆడియో ట్రాక్ అనేది, ఇది ఫిల్మ్ యాక్చువల్ సీన్ అనుకోండి, మధ్యలో సైడ్ లో 2 ట్రాక్ ఉంటాయి. ఇది స్టీరియోఫోనిక్ అయితే, ఓల్డ్ డేస్ లో ఓన్లీ 1 ట్రాక్. సో ఈ ట్రాక్ లో అగైన్ వేరియేషన్ ఆఫ్ ఒక ప్యాటర్న్ ఉంటుంది. ఇది ఎలా పనిచేస్తుంది, లైట్ దీని మీద పడుతుంది, వెనకాల దీని ఈ ఫిల్మ్ ఉంది కదా, దానికి వెనకాల సెన్సార్ ఉంటుంది. సో ఇప్పుడు మనం ఎక్కువ బ్రాడ్ బ్యాండ్ ఉందనుకోండి, మేబీ ఇంటెన్స్ లైట్, అంటే దాన్ని బట్టి ఎక్కువ లైట్ కూడా బయటకు వెళ్తుంది. ఇప్పుడు డార్క్ గా ఉందని, ఫుల్ డార్క్ అయిందంటే లైట్ రాలేదు, అటు అవతల లైట్ రాదు. సో బై కంట్రోలింగ్ ద లైట్ యూ క్యాన్ కన్వర్ట్ దాట్ ఇంటూ ఎ సౌండ్ సిగ్నల్, అండ్ దట్ ఈస్ నథింగ్ బట్ యువర్ Dolby system and also audio which is used in the movie theater. So this is again movie film audio track. అలానే ఫోటో డయోడ్ ముందు చెప్పాను. ఫోటో డయోడ్ అన్నది ఏంటిది, ఫైబర్ ఆప్టిక్ కమ్యూనికేషన్ లో వాడుతున్నారు. ఏంటిది కాన్సెప్ట్, ఇప్పుడు ఇట్ ఈస్ ఎ డయోడ్, బేసికలీ పి జంక్షన్ ఎన్ జంక్షన్ ఒక డయోడ్ ఉంది. ఇది రివర్స్ బయాస్ మోడ్ లో ఉంటుంది. రివర్స్ బయాస్ మోడ్ ఉన్నప్పుడు మనకు తెలుసు ఇట్ ఈస్ కరెంట్ విల్ నాట్ ఫ్లో ఇన్ ద సర్క్యూట్. ఇప్పుడు లైట్ పడుతుంది, డిపెండింగ్ అపాన్ లైట్ ఏమవుతుంది, దీంట్లో నుంచి మళ్ళా అగైన్ ఎలక్ట్రాన్స్ ఆర్ రిలీజ్. సో ద ఎలక్ట్రాన్స్ ఆర్ రిలీజ్ అంటే హోల్స్ కూడా క్రియేట్ అవ్వాలి. సో ఇక్కడ ఎలక్ట్రాన్ హోల్ పేర్ అనేది క్రియేట్ అయ్యి, సో ఎలక్ట్రాన్స్ విల్ గో టు దిస్ సైడ్ అండ్ హోల్స్ విల్ గో టు ద అదర్ సైడ్. అలా వెళ్తుంది కాబట్టి కొద్దిగా కరెంట్ అనేది వెళ్తుంది. సో లైట్ పడిందంటే కరెంట్ వెళ్తుంది. సో సచ్ కైండ్ ఆఫ్ థింగ్, the advantage is it can be very small and we can keep them in for the signal transmission in case of fiber optical cable. The last one is charge coupled device, CCD అన్నది మనం సెల్ ఫోన్ లో వాడుతున్న టెక్నాలజీ. So when you are taking a picture, even our old digital camera also, nowadays digital camera also outdated, everything becomes cell phone, right? So cell phone camera or the digital camera lo unnadi entadi charge coupled device. ఈ కాన్సెప్ట్ ఏంటి, మళ్ళీ సేమ్ కాన్సెప్ట్. అండ్ ఆల్సో యాక్చువల్ ఇన్ఫర్మేషన్ ఇస్ 2009 Nobel Prize was given for 2 reasons. One is for finding the optical cable, that is Charles Cow, and other 2 gentlemen they received because these 2 gentlemen, they were the inventors of CCD sensor. So CCD sensor ela panichestundi, again back to Einstein only, understanding of Einstein's way of explaining. So when light falls, when photons fall, electrons are ejected. Okay. So you have 2 layers. Right? You have 2 silicon sensor and capacitor is there. So దీంట్లో లైట్ పడుతుంది. లైట్ పడుతున్నప్పుడు ఏమవుతుంది, ఇక్కడ నుంచి అగైన్ ఇట్ రిలీజెస్ ది ఎలక్ట్రాన్స్. ఈ ఎలక్ట్రాన్స్ అన్ని కెపాసిటర్ లో స్టోర్ అవుతుంది. సో లైట్ పడిందంటే ఎలక్ట్రాన్స్ రిలీజ్ అవుతుంది. ఈ ఎలక్ట్రాన్స్ అనేది కెపాసిటర్ లో స్టోర్ అవుతుంది. ఇది మొత్తం 1 pixel. This itself is 1 pixel. So photons are falling, electrons are stored. This is 1 pixel. Alavanti pixel anappudu picture element. So if you are taking a photograph, that will, according to resolution, that will have, let us say, some 1024 by 1024 pixel, very wide photograph, a small photograph. And megapixel ippudu number anadi 10^6 ala untadi. So I am just giving an example. So 1024 small such devices and silicon sensor and capacitor, this is 1 unit, 1 pixel. Alanti 1024 by 1024 unte dantlo a pixels lo electron store ayi undi. Adi that will give some information that is connected to a processing device or computer or a cell phone or our camera, old camera. So each element is a pixel. Dantlo light padindante electron untundi. Electron unte daniki zeros and ones, one particular signal will go and that can be processed by the computer. A pixel lo light undo or electron store ayi undo, accordingly that will each pixel will give some information. This is inside view. This actual ade part anamata. Dintlo let us say 1024 by 1024. Ippudu megapixel millions lo untadi, millions of pixels untadi. So each one is part lo light padindante akkada charges accumulate avutadi. Dani batti computer will understand, okay, some light is there. Color pixel. So this is another diagram. So each pixel, each element, this is what I talk of element, right? Where is that? Yeah, this kind of pixels are arranged in an array. So dintlo light padindi ante ikkada electron store avutadi. Dani batti ee particular spot lo light padindi ante mana photo kuda ante kada, when you are taking photograph, some spots are light, light is there, some other part there is no light if it is black and white photography. So accordingly the charges are created and they are coupled, and this is the CCD, charge coupled device. This is a basic concept of our digital photography. Color photos ela vastunnayi, dantlo em chestaru malla vachina light ni, color light, maybe some color picture, color picture ni you are dividing into 3 parts using mirrors, and one will be a red filter, another one will be a green filter, another one will be a blue. RGB, we all know the fundamental colors, RGB. A color aina dantlo unna red enta, green enta, blue enta. If you are able to make that, accordingly manaku oka image anadi create avutadi. So this is a basic idea of charge coupled device. ఈ charge coupled device లో దీనికోసమే Nobel Prize కూడా 2009 Nobel Prize అనేది ఇచ్చారు. So this is one simple idea. When light falls, electrons are released. That electrons give some digital information. So this is another picture. So CCD chip అనేది ఇలా ఉంటుంది. ఈ CCD chip లో each one is a pixel. అక్కడ నుంచి వచ్చిన లైట్ అనేది కంప్యూటర్ వెళ్తుంది. కంప్యూటర్ లో ఫోటో తీస్తున్నప్పుడు స్టోర్ అవుతుంది. జస్ట్ ఒక సెల్ఫీ తీసుకుంటున్నాం, ఈ మధ్యలో ఇన్ని జరుగుతున్నాయి లోపల. మళ్ళీ దాంట్లో కూడా ఐన్స్టీన్ గారికి కొన్ని there is a role or there is a credit for taking each selfie today we are doing. So these are so my point is that no, the way we look at things, the way we try to understand, not always going by convention, not always saying wave is wave, light is a wave. Light here behaves like a particle. That is a new idea. We need a boldness to say something new and to understand science. That's how the whole science has progressed. And this 100 years, so many I have not covered because I want to confine within 15 minutes, but so many applications are there. Besides this, the whole of credit, all this credit goes to Einstein. So with this brief, I also thank each and every one of you. I also captured your own image at the beginning. So this is your image at the beginning. You are all. So I thank each and every one of you for giving this opportunity to share some of my ideas on this day. I also thank Sahya sir, Professor Garu, for giving enlightening speech, and Srinivasa sir and other organizers, and also Dr. Chandrasekhar, my good friend, for giving this wonderful opportunity. I wish you all the best. Thank you so much.